Hi, welcome to this video on ICF's Train 18. Train 18, as we have just spoken about, is a train set, and the main features of a train set are that you have distributed power, that is, you have more axles which are powered. In case of Train 18, you have about 50% of the powered axles, which means that you get really good acceleration. The other advantages of Train 18 is that it is powered by three-phase induction motors. We spoke about how AC motors are really suited for traction, and these AC motors are powered by a set of IGBTs. So you have a component called an inverter which has these IGBTs, and they help to power the train. Now I would like to just show you some of the features of Train 18. You may just peruse these slides for a short while. I will pause here so that you can read about this. Okay, so now we will talk about some of the terms in this slide one by one. So one of the things that we have spoken about is quick acceleration. Now the reason for getting this quick acceleration is that in Train 18, as many as 50% of the axles are powered. So this means that you have more powered axles, and it's more equivalent to a car than a train in which 6 axles are trying to pull 100 axles. So that leads to quick acceleration. The other reason why you have quick acceleration is that all these motors are AC induction motors, and they are powered by IGBT based inverter drives, and this means that you can get very smooth acceleration over the entire range of speed from 0 to 100 kilometers per hour. So that is also another reason why you are able to get a really good acceleration. Okay, so now we have covered 2 points. One is this point on quick acceleration. So I'll just summarize the reasons for this quick acceleration here. Sorry. You have AC induction motors, and you have 50% powered axles. Okay. So now those of you who have traveled in the Mumbai suburban or the Chennai suburban, you would have noticed that when you get into this thing called the motor coach, you typically have one driver coach. It is followed by a motor coach, and then there is a trailer coach. Now typically this motor coach, almost 50% of that is occupied by traction equipment. Okay, so there is not much space to sit in a motor coach. But now what we have done in Train 18 is that instead of occupying this space with traction equipment, this traction equipment has been shifted from here to the undergear. That's what we mean by underslung suspension. Now for those of you who are not in don't have an idea about, say, design of rolling stock and bogies, it's quite difficult to visualize how big a thing this is. But actually creating a bogie like this with the traction motor located here is actually a very great engineering task. It's not easy to achieve something like this. We'll talk about this in detail. So this is also one of the salient features of Train 18, that you have the motors in these bogie, and the other traction equipment like the traction transformer are located and the inverters are located in this undergear part. What are the other features in this train? You have GPS based passenger information system. This is well a technical leap, but it's just something which can be fitted to any other coach also. Then all of you know that we are introducing bio toilets in trains, and now this particular train also has vacuum toilets. So we have bio vacuum toilets in Trinity. The interiors now, in all the coaches that you travel in, you have LED lighting. The problem with LED lighting is that the lighting is very sharp and sometimes it's not very soothing to the eyes. So here you can see that the over the lights we have a diffuser. It's done by putting polycarbonate diffusers, and this spreads the light into the entire coach, and as a result of which the ambient light is more evenly distributed and you don't have that sharp light in the eyes, so it's more comfortable. The other important point is the automatic doors. The doors are pneumatically operated, and the footsteps, they expand and retract towards the platform. So there is very little gap between the footstep and the platform, making it very convenient for the passengers to get into the train. So this is one more important feature of this train. So the important features, well, you have distributed power, you have underslung equipment, you have almost 50% of the powered axles, you have special bogies which can carry the traction motors, you have bio vacuum based toilets, you have diffused lighting, you have automatic doors and footsteps. So really it's a big leap over the conventional trains. Okay, now this is just a 3D drawing which shows you the various location of the components. This part here is the bogie. You can see that the bogie is underslung. Below the toilets you have the biodigester tank, the traction transformer. Now why do we need a traction transformer? You have 25 kV OHE at the top, so you need to step it down. So to step down this voltage you use this transformer, and after this transformer what happens is, I'll just detail the other steps here. This is quite interesting. After this transformer, the alternating current gets converted to direct current. That may be surprising for some of you. And then this direct current goes to a device called an inverter. And this is where you have these IGBTs. And this inverter then helps to convert this direct current to alternating current. Now the difference is that this inverter is able to produce alternating current of any frequency. As you can see, this is a low frequency, this is a high frequency, this is also a high frequency. And it is this property which enables you to smoothly run AC motors. So it's a very interesting point that to power AC motors, you first need to convert the alternating current to direct current, and then the direct current goes to an inverter, and that in turn powers the AC motors. I'll not go into the details of this technology, but this is a standard technology all over the industry for running AC motors. And the reason we use this technology is that it makes a lot of things like smooth acceleration we spoke about. And the other point that we spoke about was regenerative braking. So all that becomes really possible when you use this type of technology. And the downside is that all this conversion process and control of this conversion process, it becomes really complicated, and that's why you need these really powerful traction computers to take care of the entire process. So here we have a component called the auxiliary converter. So the auxiliary converter is basically, you need a converter to provide three-phase AC for the motors. That's called the traction converter. And then you need another converter which powers the lights, fans and air conditioners, and for that we use this auxiliary converter. All this equipment is in the undergear, as you can see in this image. Okay, now the front part is aerodynamic, and that has been made by putting an FRP nose cone. There have been talks of putting a metal cone because ICF has discovered that this FRP cone, it suffers greatly when you have a cattle run over. Here you have the coupler, that is the connection between the two coaches, and this coupler is also covered for better aesthetics. And the whole idea of having this shape is that you are able to have reduced aerodynamic drag, and that results in better energy efficiency. Okay, so now we talk now about the bogie, and this is a very important point because the bogie of the Train 18 is actually a very important design in itself. Now first, before we get into this, I would like to talk about in general about what bogies are. So bogies, they perform two very important things. First is that there is the weight of the coach, and that weight has to be transferred to the tracks. So their first act is that of weight transfer. They also do one more important function. Any one of you who has ridden even a bicycle, you know that you need to turn the handlebar to negotiate a curve. So in the train, there is no handlebar. So the handlebar that you have in the train, which enables you to negotiate the curve, is actually this bogie. So the bogie has two very important functions. One is the weight transfer and the other is curve negotiation. Now before we just go on to talk about this particular bogie, I would take a couple of minutes to talk about the Casnab bogie, which is a more simpler type of bogie which we use in our freight stock. So in a Casnab bogie, what happens is that you have a component called this center pivot here. You can see this little pointer there. This is center pivot. So what the center pivot does is that the bogie can turn 360 degrees about the center pivot. So this enables the bogie to do curve negotiation. And there is one more aspect, is that the majority of the weight of the coach or the wagon also comes on this Casnab bogie on the center pivot, and from this center pivot it goes to these springs, through these side jaws, and then to this bogie, to these axles. So the center pivot, it performs the role of rotation as well as carrying the weight of the wagon. It's not possible to combine these two functions in this bogie because we are mainly looking at transfer of commodities through wagons. But when you try to design a coach for passenger carrying, this is actually not a good idea. We have spoken about the two major functions that a bogie does and seen the much simpler bogie, the Casnab bogie. I will now come to this bogie of Train 18 and try to explain to you as to what major features are there in this bogie. Okay. So the biggest challenge in Train 18 here is that in addition to these two conventional functions that a bogie must do, weight transfer and of course acting as a handlebar, this bogie needs to do one additional thing, and that additional thing is to take care of this motor. So you can see here that there are the two traction motors. This is the traction motor, this black thing. And in general, when it comes to passenger carrying coaches, we want to separate these two functions, the first two functions that I spoke about, carrying the weight of the coach and acting as a handlebar. So what is being done here is that here you see two big blue structures on the left and on the right. So these two blue structures are what we call air springs, and these air springs perform the first function, that is of weight transfer. So weight acts on these blue springs, and from these blue springs it gets transferred to these arms of the bogie, and from there it goes to this component that we call the axle box, and from there we reach the wheels. So the weight transfer, it happens through these big blue air springs, from there to this frame, then to this axle box and then to this wheels. This weight transfer has got no role in turning the bogie. So that dedicated thing is being done by these big blue structures. And here we have the center pivot, which is very similar to what we saw in case of the Cessna bogie. Only thing different about the center pivot is, unlike the center pivot of the normal bogie, this performs only the handlebar function. It's just not involved in any other activity. It is doing just this handlebar function of rotating the coach. Okay, so we have separated out these two functions in this bogie, and then we have this third most important component called the traction motor. Now the traction motor, you would see that here there are two clips. Here, this area you can see. I hope it's visible. Just focus on this area where this marker is rotating. Here you have two clips by means of which this traction motor is hanging onto this frame. Here you can see the frame. The traction motor is hanging onto this frame. Now the special thing is that this traction motor is hanging onto this frame, and this frame is transferring its weight to the wheels through this spring. So this is a very important concept. What is happening is that the weight of the traction motor is being transferred to the wheel through a spring, and this means that the bogie does not have any unsprung mass. This is a very important concept in bogie design, that whatever weight you add to the bogie or to the coach should reach the wheels only after passing through a spring. I am slightly dumbing down the language to make it easy for even people who don't have a technical background in this subject. So the basic idea is that whatever weight you have in the coach, whatever weight you have in the bogie should reach the wheels only through a spring. Now by hanging the traction motor here on this frame, what you have done is that you have made sure that the weight of the traction motor reaches the bogie only through this spring. This is a very important concept, and in fact this feature is not there even in your modern rolling stock like the WDG4 locomotive or the Wagonite. And a part of the weight of this traction motor actually hangs directly on this axle. Here you see that there is no connection directly between this motor and the axle. In other conventional rolling stock like the locomotives, you see that there is a connection here and this motor is actually mounted on this axle. Here we don't have this, and the reason why we don't have that is that we are able to transfer the weight completely through these springs, and the reason why we do this is to give the bogie a better riding characteristics. So I know that this slide has been slightly heavy, so I would like to just summarize the major things that a bogie does. Pardon me that you have a RMPU in the background. So a bogie does weight transfer. This weight transfer happens through these big blue air springs that I just showed. The second thing is that there is turning, and this turning happens through the center pivot, which does not carry any weight. So there is no weight which is carried here. That's a very important concept, unlike what you saw in case of the Cessna bogie, which deals with goods or freight stock. And the third important concept is no unsprung mass. This again is an extremely important concept. You have the traction motors in the undergear, but the traction motors carry their weight to the axle through a spring. And these three characteristics make it possible to give you a very good ride quality, and they make the faster acceleration possible. See, if you have a really poor ride quality, you cannot really go at a high speed of 160 kilometers per hour. You will be stuck at a much slower speed. Okay. So now I'll just get rid of these annotations. Just give me a moment. Okay. So the next point that we are going to talk about is we're going to talk about the RMPU or the roof mounted package unit. The roof mounted package unit is just a fancy name for the air conditioner. So Actually, this term comes from a previous era in which the AC unit actually used to be underslung. It used to be under the coach. So now we actually put it on the roof. So this is your AC unit. It's called the roof mounted package unit for obvious reasons. It's there on the roof. Now this roof mounted package unit is there on the two edges, and this structure that you see here is that the air duct. So the air flows from here and it goes through the entire coach. And while you may not believe, but this ducting is actually responsible for good cooling. If you do improper ducting and you have a really good AC, you will not have comfort in the coach. So it's very important that you have a good ducting design for uniform distribution of the airflow. It's a very important component of coach design. And in fact, these days a lot of workshops are actually thinking about methods to clean these ducts, because over a period of time they accumulate a lot of dust. And even robotic cleaning is being contemplated, because this also has a very important role in ensuring good air quality. So these are the interiors of the coach. That's the exciting part. We have spoken a lot about technology. So now we'll just talk a bit about aesthetics. You see the first class coaches, so comfortable. It just looks just like an airplane. This is the first class entry. You can see that the doors are automatic. They open automatically when approached by a passenger. This is at par with what you would find in an international train. These are the second class coaches. Similarly great interiors, but yes, the space is much lesser. You also have space for wheelchairs, so it's really disabled friendly. Although the seating capacity is quite high, you have a lot of free space for movement. This is because of better utilization of space. You can see the toilets, which are at par with airplane toilets and disabled friendly. This is the fully sealed gangway with exterior fairings. Gangway is basically the area which takes you from one coach to the other, and this part is fully sealed. So you really don't have the discontinuity that you have in a ICF coach or a LHB coach. This is the sliding footstep that I spoke about. This just comes out towards the platform. See, this diagram is much more clear. Here you can see that it's flaring out. You have some more nice features like this continuous LED lighting. You have these concealed roller blinds. Roller blinds are just the curtains. The rubber which is being used is halogen free, so it's more environment friendly. And ICF is not planning to stop with just Train 18. There is also a talk of making a Train 20. Train 20 is actually an aluminum car body coach. And as of now, although Train 20 is being spoken of by ICF also, the modern coach factory has already done a tender with a Korean company for technology transfer for aluminum car body coaches. I'll not talk much about this because aluminum coaches are still pretty much in the design stage. But the main idea of aluminum as coach for coach construction is that aluminum is a really light metal. It's 100% recyclable, so that makes it environment friendly. Although the fact is that aluminum production itself, it takes in a lot of electricity, but it's fully recyclable, hence it's considered to be an environment friendly metal. There are also energy savings during the lifetime of the coach, as the coach is much lighter. And the biggest advantage of aluminum is that you can actually have paintless coaches, because the material, it is corrosion resistant because it forms a protective layer of aluminum oxide over it. And a lot of modern railways are therefore experimenting with aluminum car body coaches, and you might see the same in Indian railways also. So that's it about Train 18 and about the modern train sets that railways may try to introduce in the days to come. Thank you. It was a pleasure to tell you about these technologies, and I hope you enjoyed this lecture. Thank you.